let's have a look at the software architecture transformation and assessment. That is, you've transformed the various designs into an architecture, the requirements into an architecture, and that's a fairly standard, straightforward process that I won't describe here. But what I will talk about a little bit is the assessment of it. Now, with agile projects and architectures to support agile software development, you tend to have to produce a fairly general purpose architecture. It has to be general enough and robust enough that it can take whatever modifications, alterations that you have to do to it as the problem unfolds and as the solution unfolds. You could well find something that means you have to go back and change a fairly major part of the architecture. So to try and avoid that, you start out with a very general purpose architecture in the first place. Now that usually means that you have a fairly modular architecture, and that will be fairly good for maintenance and fairly good for modifying things, particularly the architecture itself, but it will cost you a certain amount in performance. Now, for most commercial applications, that's really not a big problem. But the question comes around evaluating an architecture. The first question is, when do you know you've done enough? Well, the criticism has been that software architects tend to want to finish the design and won't release the thing until it's completely finished, and if they're satisfied it will do everything that's needed. This is not, it's not desirable, it's not necessary, and it just gives the architects a bad name. What the criteria for have you done enough is when everybody can see what they need to see in the architecture. That is, for the part that you're about to implement, the business stakeholders can see that yes, it's there, it's represented in the system. We don't try to require that they understand what they're looking at, but simply that they can see yes, it's been taken care of. The developers need to see what it is they have to do. So they need to see how what they're going to do fits into the structural part of the system. Now that's easy to say. You can do a just general purpose critique, have some of your colleagues look at the architecture and try to review that in just a general fashion. And that's well and good. That will work. But it is better, or the better way of doing it, that's fairly robust and fairly universal, is to actually do a run-through of all the scenarios. Sorry, when I say all of the scenarios, that could be a little bit onerous. Pick out a selection of the scenarios that are actually going to test both the happy case, that is, it does what it's supposed to do, and the exception cases. That is, does this architecture handle the expected exceptions? And you probably should put in the curliest ones possible. The easiest or most public way of doing this is through the class responsibilities collaboration method that was first proposed and described by Ward Cunningham and Kent Beck back in 1998. It's a very good method, and that is, you have people sitting around a table, and they all have responsibility for some collection of classes or objects in the system, and there is a token. The whole idea of the token is that whoever has the token describes what the objects in their responsibility do. Now, you start with some sort of a transaction or interrupt to the system, some event, and that usually starts from the user interface. So something in the user interface triggers an event, and you trace the execution or the flow of control in information and processing through the system. So if an object calls another object or sends a message to another object, the token passes to the owner of that other object. They then describe how their collection of objects deal with this responsibility, and if necessary call on other objects. It works pretty well, and the token enforces the discipline that it's difficult to then overlook something because there's obviously a gap, and anything extra is a bit harder to identify. But it's a pretty good, robust way. Now, if you can do that, if you can go through all those scenarios for the expected cases and the exception cases, then you've probably got it reasonably right.